Unfortunately, there was no audio.
Oh, really? That's pretty funny.
Yeah.
Yeah, recording sometimes there are always issues. Like the recording that I have, the video quality is pretty terrible. But
I wish Hangouts had a default recording because I use Teams at Office and that does, which seems to work. But
I see. Wait, so the software from Microsoft Teams, it automatically records the video for you?
not automatically, but it has a record option.
Oh, okay. That's interesting.
And then, yeah, you can record directly from that.
Yeah, I should check it out. I never know Microsoft Teams has has such functionality.
Yeah, I guess it helps. One of the few great features of Teams, I guess.
Mm-hmm. Yeah, because we have our Office 365 subscription in our university, so we get to use the Teams. I just never know why it would be a useful feature, I guess.
Yeah, fair enough.
Oh, yeah. It does seem...
Yeah, I think the web version, all three records just fine as well.
Yeah, I'll definitely
So
check
don't
it
have to
out.
download. Cool.
Yeah, it looks very viable. I'll definitely evaluate it, see if it's a better method than what I'm currently doing. Yeah. So Ali, did you get a chance to maybe look at the implementation, dig into a little bit maybe?
I looked at the implementation matters repo that the folks released.
Mm-hmm.
I didn't try putting it into CleanRL yet,
Mm-hmm.
but I don't mind trying that out today, this weekend. I'll have some time.
Yeah, no pressure. I don't want to say, you must do it, but it just if there's anything that I can help, let me know. Either to help you to set up experiments or anything. So I actually have a couple demo file that you could take a look at, which is something that maybe we'll talk about today. And yeah.
Okay. One thing was I was playing around with the benchmark shell script.
Uh-huh.
And one thing I was trying to do was parameterize some things, like the number of runs that each run does. Right now it's just 2, so I'm trying to make that a variable that I could change sometimes.
Uh-huh.
And this was kind of hard to do it because it's basically running the same type of for loop, but with different script and then different arguments for the parameters.
Could you elaborate? What do you mean change the number of runs? Like the number of episodes?
No, like the actual number of seeds you use and then run over them. So the first for loop is for seed 1 through 2, and then you just run that script.
Right. All right. Oh, I see the bash script. Okay.
So I basically added a parameter. The things I've been parameterizing are
I see. Like you want to use a bash script sort of in a more automatic manner to try out different parameters, other than just seed.
Yeah, so for example, I'll just share this initial thing that I changed.
By the way, feel free to share part of your screen with that, or post a picture in the Slack so that it may help me better understand it. But tuning variable with the command line should be something that is not complicated.
And it's something someone mentioned last week was maybe switching from just the batch script to a more config-based approach, like a YAML file. Might make sense, but this is all I changed. This is just yesterday. I changed these things. I'll make a screenshot and save it in Teams in the Slack.
Okay, sounds good. In the meantime, I'll start sharing my screen. Maybe today. Maybe today there's not going to be a lot of people joining us, so I guess we'll just get ready to get started. Let me know if you send that thing into Slack. I'll definitely check it out after you post it. We can do that in this meeting as well. Okay, let me see. So what you did?
Yeah, just so that the last value in the loop is now a variable called numRuns, and then just changing. The only thing I changed was I was running on a server I have that has two GPUs,
Uh huh.
so I was getting CUDA out of memory errors just because it was running all of them on the
Oh,
same.
right, right, right. So what
So
have you tried to run the first two things? The num core is equal to 2, and then export this thing.
I did, yeah. So I run that TypeScript as it is.
Oh, it
Um,
still ran out of memory.
yeah, so that's
Oh,
why I set the CUDA to negative ones, so then use any of them for now, because none of these are very large or take a lot of time training anyway. So
right,
I
right.
think GPU storage was that important.
I see, I see. Yeah, sorry about that. I only have one GPU to test with.
Fair enough. I'll probably play with it a bit more and see how to get it in the sort of config that I want.
Yeah. Yeah. I'll definitely be interested in now that there's a more realistic use case. I think it would be worth it to look at the maybe like a configuration file. But the configuration file really should be like we can have a configuration file, but there really should be a separate Python file that translate the configuration file into command line arguments or something like that. Um,
Yeah,
yeah, because
like config parser allowed you to use like a INI file or like a YAML file,
yes, yes.
but then you can just read that or call it from somewhere else.
So I was looking at this project actually. Do you guys are you guys aware of the stable baseline zoo?
Yeah,
Yeah.
tomorrow Zoo.
Yeah. So they have a lot of, for example, hyperparameters set up already. So if we could find a way to while we do this translation, if we could translate the YAML file from the hyperparameters of let's say here, and then
Mm-hmm.
just into the cleanrl command line arguments, I think that'll be awesome.
Makes sense. Yeah.
Yeah, but for yeah, I mean, if this is something that you're interested in, definitely let me definitely give it a try. I'll be very happy to merge it into the repo.
Cool. Okay. I'll dive
Um,
into that this weekend.
yeah, yeah, yeah. You know, if you're interested, if it really helps with your project, you should, and you know, I'll try to incorporate it so that it could help other people as well. All right, so let's start talking about implementations. Maybe I'm guessing we're probably not going to be expecting a lot of people. Oh, actually, another person joined. Hello, Lucas. Hello. I'm guessing your mic is probably not working. But yeah. By the way, a tip: if your mic isn't working, another potential is to join the. Oh, I see. I see. Okay, yeah, maybe another time. Okay, I guess I'll just get started with the implementations. So if you look at the paper, one of the things, by the way, I apologize for the number of tabs that is open. I tend to procrastinate on closing tabs. Um, but if you look at the paper, one of the technique was reward scaling. And it's also the technique that resulted in the one of the larger divergence in the experimented results. Like with the algorithms that ran with normalization of the rewards perform much better than the ones that doesn't use it. So that was my primary technique of investigation. And then let's read this together. So it says, rather than feeding the rewards directly from the environment into the projective, the PPO implementation performs a certain discount-based scaling scheme. In this scheme, the rewards are divided through by the standard deviation of the rolling discounted sum of the rewards. And it says without subtracting and re-adding the mean. So that's actually something that is interesting. So I don't know if you have guys, if you got a chance to look at their repo. But a couple things that I dig out in their repo is their reward filter. So first of all, they have this running stats that keeps track of the mean and the standard deviation of a running time series. So if I do something like this and just run it here, and then I say rs equal rs, I need to give it a shape, but if you're just going to feed in the number, you can just say feed in a shape of a 0, and then you can just say rs1. Really? Should be the right way to use it. Oh, I see. It's push. Sorry. So if I push a 1, and then I can say rs.mean is 1. If I push 2, and then the mean should be 1.5, and then I can say rs.standard deviation. So it's just something that keeps track of this mean and the standard deviation, and then they later on that uses this running stat to the reward filter and Z filter. So let's talk about Z filter first. The Z filter is something very simple. The Z filter is saying I am going to add the data to my running stats, and then I'm going to minus the mean and divide it by the standard deviation and return the result. So that's what the Z filter does. And they also have this reward filter, which is a little bit more interesting in some sort of way, because they add in the gamma of the reinforcement learning, the discount factor, into its calculation. So instead of just pushing instead of just pushing the input into the running stat, it actually first calculated returns by time and multiply by the discounted factor, and then plus the new reward. So it's almost like doing the discounted returns in the reward filter, and then push the reward into the running stat. And then it has a reset function that resets the returns if that function is called. But here is the problem that I am really confused about. If you look at their environments, eventually, if you search for a reward filter, you found there's only a few places that mention it. So the only place that reward filter is used is self.reward filter. But then if you try to see where reward filter is used, it's mainly in this custom in file. It's not used anywhere else, so we can examine it. But the problem is the reward filter's reset function is never called, right? If you look at just this part of the code, can you guys see something different, or would you agree with me?
I tend to agree. So maybe they keep the mean of the returns over all the episodes in this case without resetting.
But the problem is, if you look at the implementation of the reward filter, every time you put an X in, the X is multiplied by the original returns times the gamma, which means the gamma will be applied as long as you run this algorithm for thousands of episodes. You're always multiplying itself by 0.99 and then adding the new rewards, you know?
I see.
Yeah, for me,
it should be. It really should be reset every episode, right?
Yeah, exactly. It should be reset after every episode. So that's the thing that was really puzzling to me when I was trying to recreate their experiments. But this is what we have. So
like in custom end, the reset method has a state filter reset.
But here's
reward filter reset. Yeah.
Yeah, so here's the more interesting problem with the state filter reset as well. So the state filter reset actually doesn't reset anything. So if you look at the state filter, it starts with an identity, which is here. And then when you call its reset methods, it does nothing, right? So the author really does the filter sort of in a layered approach. So he first put an identity state filter, and then he either creates a Z filter or a state with time filter. So the previous state filter would be the identity filter. And then if you look at the Z filter, when you call the reset filter, it just says the previous filter reset, but that's just going to call the identity filters reset, which does nothing. The other case is that if it calls the state with time, same thing. When you reset its filter, it's going to set the previous filter, which is the identity filter, which has a reset that does nothing. So in any case, the state filter also doesn't do anything. Does that make sense?
That's weird.
Yeah, it's really weird. I'll put it here for comparison. It's not letting me. Okay, well, my Discord live can probably be closed or whatever. Right, so if you look at the stay with time, which is right here, its reset is yeah, but anyway, it's just something that I found really weird with their repo. I don't know whether maybe when I did the experiments, the code was updated or something that they haven't put it into this repo. But yeah, so that was one of the issues when I tried to implement. And when I actually do the implementation, so I did a couple experiments. So the first thing was to do the reward normalization. So what I did is, so I added the running stats and a Z filter, reward filter here. And then I said, so instead of using reward filter, I'm using the Z filter. And then I have to set center equal to false, which may or may not be the right thing to do. By the way, just want to add something real quick. If you look at the reward filter, it actually has a comment that says incorrect reward normalization copied from OpenAI's code. Like, I have no idea what they're trying to say right here. If it's incorrect, why is it being used by default? So if you look at the repository in the README, it tells you to use a setup agent to set up your experiments. And then if you look at the setup agent, it says the default normalization rewards is return methods. And then if you go back here to the custom environment, you found that the reward filter is the one that is being used by default. But if it's the one that is being used by default and you have a comment that says it's incorrect, that also doesn't make a lot of sense to me, you know. But yeah, so anyway, so if I take a look at this, reward shaping, oops. Right. Running stats and scale observation RT times reward. Add the reward into the running stats. Okay, so this is kind of what they did in a running stat in the reward filter. They just never reset it, right? But anyway, sorry. For my experiments, I just set center equal to.
Just a question.
Yeah, go ahead.
That's it.
Did you say you have a question?
What is the previous filter that is used in, for example, reward filter?
What is the what?
There is a prev underscore filter. I guess it stands for previous filter,
Oh yes,
which is,
yes, yeah. Are you talking about their code?
yes,
Yes. So the reward filter is simply the previous filter. In this case, it will be identity.
identity.
Right.
I see.
So if you call the filter, it's gonna do nothing. It's just gonna return whatever has been given. And if you call reset, also nothing will be executed.
This doesn't make much sense.
Yeah, it doesn't make much sense, right? But
Thanks.
yeah, but anyway, for my experiments, I set the Z filter center equal to false, and let's take a look at what it does. So what that does is that if the center, then you use x minus the mean, but if it's not center, then what you would do is you first of all you minus the mean, and then you divide it by the standard deviation, and then you add the mean back, right? So that's basically what it does. So that's the Z filter that I use for the reward, and I also clip by 5, which is also the one of the things that's being mentioned in the paper as well. So it says the reward clipping, depending on the implementation, is usually clipped by -5 or 5. There's nothing too magical about it, I think. But yeah, so that's a reward filter, and we can take a look at where it's being used. So that's just being used in the reward. So I have a real rewards that keeps track of the rewards that we're going to log into the TensorBoard. But it was the reward. I just replaced the reward step with the whatever comes out of the reward filter. And remember, all of the optimizations are done based on the rewards. So the real rewards. This is a fairly simple code change and shouldn't result into too many complications. And then I just log it by using the real reward.sum. So that's the first thing that I did for the reward normalization. And the other thing that I did is advantage normalization. So if you look at one of the people's code, so this code from Zhang Chuheng. Zhang Chuheng. So his implementation, if you take a look at it, instead of doing the normalization of the rewards, he does the advantage normalization. So he simply says advantages minus advantages dot mean and divided by the standard deviation. So that's the thing that I'm doing right here for the advantages. So those are the two variations that I did, two experiments, and here are my results. Right, so let's see what is actually being selected in here. Right, so this is the Hopper bullet env, which I forgot. Oh yeah. This is Hopper bullet env. Sorry, one of the experiments that I did have these gym environments, this continuous domain that only returns a reward of 1. So in that case, the Z filter wouldn't do anything different because it just returns 1. I guess the standard deviation would be 0, but that should be something that be handled by the reward filter, or something like that, right? Yeah, but anyway, so this is a hopper env, and in the hopper env, the vanilla one without the reward normalization performs the best, but eventually they perform very similarly. And then in this Walker domain, which is the domain that has been experimented by their code, I think this is Walker. Oh, sorry. The bottom one is a Walker, and the top one is humanoid. And in this domain, in Walker's domain, if you're doing the reward normalization, it performs very poorly. It only achieves the reward of 56. And then if you use the advantage normalization, it performs the best. Okay. And then further down, in this experiment of humanoid, advantage normalization also appears to perform the best, and reward normalization is performing very poorly. I wouldn't necessarily. So, a couple things to notice is that in the paper, when they did this ablation study, they're really saying we have implemented all 8 tricks. Now we're just taking out the normalization reward and see how it performs. But when I did this, it's more of I've implemented none of the 8 tricks. Now I'm just going to implement the normalization of rewards and see if it performs better. So it's not necessarily a re-implementation or reproduction, but it's a different way to do the ablation study, I guess. But yeah, so this is what I did for this week. I didn't get a lot of chance to work on this, so I just try to code up something simple and then give it a run. And it didn't exactly reproduce the results. I think maybe for next week, what I might try to do is to instead of using the Z filter, I might try to use the reward filter, but I think I'm gonna try to reset it instead of just doing what they did. But yeah, any comments?
Good job so far. So
Thanks.
I had a quick question, I guess,
Yeah.
regarding the tricks 6 and 7.
Okay.
Where they use the observation, normalization, and observation. I was wondering if they still need to use clipping with the normalization, because basically when we normalize, it comes back to between like -1 and 1, right? Or something similar.
Right. Well, the problem is, even if that's the case, if you have outliers, let's say -100, and when you normalize, even though the -100 will still be squeezed in within the -1 and 1 interval, other values will be pushed a lot closer to the mean, right? Because you have that outlier.
Yes.
Yeah. So
that's why we want to clip before normalizing, maybe.
Yeah, I think so. That seems to be a very plausible explanation for it.
Indeed. Same thing for the rewards, I guess. I see. Thanks.
Right. That makes sure that when you normalize it, it always kind of still doesn't have outliers, and you still have a shape that is not too squeezed, I think. But yeah, that's the implementation. Does anyone try to implement and find it difficult to start with, not knowing how to use a library? If there's any question with that, or just something that you find it difficult to use it, this is something that we could talk about as well. And of course, if you have any more questions or comments, this will be the time to talk. I don't have a lot to talk about right now.
If there is no question, I have another quick one regarding the reward filter again.
Okay.
Did you try any experiment where you reset the reward filter with the environment?
Um, I haven't tried that experiment, but let's play around with it. The other thing to keep in mind is that even though the reward filter is reset, the returns that are already added into the running stat does not get reset. So what that means is, let's run a simple experiment. So this is the reward filter, right? And I just say RF equal to reward filter. Right. And I'll give it a shape. And then the gamma, let's put at 0.99, which is fairly common. And then if I say RF1, it's going to give me that. And then the more I add in, you see the lower it gets, right? So that's where the discount factor kicks in. That's
Yes.
really bringing everything down more and more. And if you don't reset it, this is how it's going to be. That's why I find it really curious. Of course, the speed is going to slow down because you have more samples that are a little larger, I guess. Like, for example, it takes a long time to go from 0.5 to 0.4 or something. But it's going to go down. That's the bottom line.
Sure.
And even if you reset, let's say rf.reset. Okay. When you do one, it's still going to...
the old running stat.
Yeah, because of the running stat doesn't get reset. So...
Isn't there any method to reset that one?
I'm pretty sure you can reset the running stat. I'm just not sure if you would want to. Like, is there... Because if it doesn't degenerate into this case, let's have a simple experiment, right? Suppose you're dealing with carpool, and then you're having 1, 1, 1, 1, 1. Let's say just 5, 1 as a reward, right? And then if you start with the 0.99, okay, and then you say RF1, 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 RF1. Okay, and then the episode finishes, and then you say RF.reset. So this should be a lot more realistic. And then you run it again, you receive 0.99. Suppose you also run it for 5 episodes, and then you reset. I wonder what this is going to be. See, it moves up, right? So from 0.66, it moves up to 0.72. So maybe if you reset properly, it should be more reasonable, right? We can also do like a giant for loop to test it out, right? I don't know. So this should be a fairly accurate, well, somewhat accurate representation. So for 100 episode, and at each episode, it could end at from anywhere from 0 to 200, and then we're saying, and we're resetting after every episode. Right. And then if I say RF1, it's still very small. That's interesting.
Maybe there is another trick in that running stats.
I don't know. What if I stretch it? You know, what if I run it like 10,000 episode? How's that gonna turn out? It's actually taking quite a lot of time. And if I say RF1, it actually kind of converges, right? So you see here, it's 0.426, and here is 0.427.
Yes, close enough.
Yeah, it's very close. That's very interesting. I wonder how the reward filter is going to result in, and I want to see if we don't call the reset method, how is it going to turn out to be? It's smaller. Let's see if it's a lot smaller. It's also not a lot smaller, but it seems pretty problematic. I don't know. But yeah, this is what I have for this week. Any more comments or questions? Things to discuss? Oh, by the way, Lucas, if you send anything, I probably didn't see it. If you want to send it, feel free to send it into send a message to from the Slack channel to me, and that way I'll be notified. But yeah, do you guys have any more questions? If you don't, I can also share a little bit of DQN playing with the Atari thing.
Sure, why not?
Yeah, so I was experimenting with DQN with CNN. The problem is, for a lot of the implementation that I've seen, they actually use a lot of wrappers. So an example would be like this: they have this fire reset wrapper, max and skip inv, process frame, blah 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 blah, and this is how you make an environment that supposedly that'll help the agent learn. Um, but even if that's the case, when I ran the algorithms on it, it's very strange. It doesn't really learn. It's even it could learn in the beginning, it just kind of deteriorates, and that has been a very frustrating debugging journey for that. So yeah, so see here, and we can visualize agents' performances as well. So it has a lot of these spikes. I don't think these spikes would be achievable by random agent, honestly. Um, Maybe it is, but I don't know. But you can see at the end of the episode, it converges, and then there's one value that always has the largest Q value, and then it just always loses. But if you go to the beginning of the episode, so this is what the random agent does. Because in the beginning, it's highly exploratory. Somewhere in the middle, the agent should learn something. Well, the video is not really showing anymore, I suppose. Well, that was the first time it wins.
A question regarding the code in the make underscore and function.
The what?
Make
Make
and
env.
yes.
Okay, right.
Maybe the I'm image to PyTorch should be the last wrapper you use.
Maybe it is the case. Well, so this one is actually directly taken from a code base by this person called Shmuma. I actually personally enjoy his implementation a lot. His code usually just works out of the box, and I don't have to look through a bunch of files to know where the code is defined. So he actually wrote a book called "The Deep Reinforcement Learning Hands-On," and it's a book that I bought. Um, but sometimes it's helpful. Like he essentially does more comments in the books, but in here, this is what he has. And I personally tried it and it works. So I think my next step would be try to mold all of his code into my repository and see, trying to figure out what's the thing that changes. Because I figure there might be some sort of major bug going on with the DQN. Or maybe not, I don't know.
I see. I thought it was the stable baselines wrapper that were used.
Yes, yes. And there are different wrappers, like the gym itself also provides a wrapper, which didn't work which also didn't work quite well.
Max time limit.
No. So if you go to gym wrappers, so this is a gym's official repository, and they have Atari pre-processing.
Oh, I see.
And it has a bunch of things that was basically mentioned here, like for example the max and skip. Oh, sorry, this is just max falling. Okay. For example, grayscale or whatever, or frame skipping, no op reset. It's just a lot of things that's also being used in the stable baselines library or baselines library.
I think I've seen this somewhere else too. I don't know where. I got the gist. Anyway.
Right. But yeah, it's. I'm definitely gonna try to make it work. Next week, we have this machine learning reading group that is going on in our university. It's just. It's more like a amateur. Well, I wouldn't say amateur. It's more like an interdisciplinary reading group that focus on various aspects of machine learning. The last person was doing a presentation on transformer, and before that, some people were doing a presentation on cognitive science. So I figure it might be interesting if I did a presentation on DQN, which is an easy paper to read, and also one of the more foundational papers of the reinforcement learning. Well, deep reinforcement learning, I should say.
Good luck.
Thanks. Yeah, and I really wanted to show them that by using this library, I can actually see the agent's performance at each different time step, show them various things, and I can show them if you want to reproduce it, you go here. Well, you can download the file that produced it. Not exactly the way to reproduce it completely, but there's a lot of things that are very documented. But yeah, just how's everyone's week?
Could have been better.
Too busy.
Did you say could not be better, or
Could have been better.
could have been better? I see. I got
Too
you.
much stuff. Not the usual ways. Is someone counted?
What was that? Pretty
Yeah, by a window, so a lot of cars driving by.
Oh, I see. Yeah, I was pretty busy myself, having a lot of struggle with the research, trying to figure out where to go. Yeah, doing reinforcement learning research is hard, guys.
Nothing of value comes easy.
Uh, Luke here seems to be very interested in model-based RL. I feel like that might be something that we can definitely look into the future. Something that I really want to take a look at is mu zero. Definitely something that I think it may be interesting for a lot of people because I feel like it's going to be an easier algorithm than the AlphaGo because AlphaGo is a lot more complicated and very difficult to test. But with mu zero, you can test it with Atari. So um, and also by the algorithm itself, it seems self-contained. You don't need a model of the game. So that's for that. Um, well, we also don't have to stretch the meeting to 1 hour exactly. Does anyone have any more questions, things you want to discuss, comments?
No more question here.
Okay. All right. Let's end this meeting earlier than usual. Then. Thanks everyone for coming. Really appreciate it. And for the next following week, I would highly encourage you to try out some of the experiments. So if you look at the amount of code change that I have to do this experiments, it's fairly minimal. Um, it's basically just implementing the running stats and then initiate a reward filter and then modify a couple things and that's it. So a lot of the tricks that are mentioned in the paper, I feel they could be implemented in similar ways that are extremely simple. So I would encourage you to give it a try. For example, Adam learning ray annealing should be something extremely simple. It should be just like for example, if you look at the DQN file, it has a linear schedule that maybe you could use. You could just use a linear schedule to tune the atom learning rate as the time steps go by. Just a lot of things that I think it's very easy to experiment. I would encourage you to take a look at these and see which one would be more interesting to you and just do a little experiments to get started, see if they improve the agent, try it out on a couple of environments. But yeah, anyone have any last minute questions, comments? All right. Thanks everyone for coming. I hope you have a very good weekend. And I'll see you next Friday. Hopefully also at the same time, 5 p.m.
Thanks. Have a good weekend.
Thank
Goodbye.
you. You too. Bye bye. Okay. With that, I will conclude the meeting.